Okay, for this lesson, we are working on rates of change and initial values from tables and graphs so that we can write an equation that represents the situation. So first we need to review what it means to have an equation that's in slope-intercept form. Well, slope, remember, is your m value, which we now call the rate of change. Y-intercept is your b value, which we now call initial value. And when you put those things together in the equation of a line, it's called slope-intercept form. Your slope is right there, your y-intercept is right there. And again, the only thing really different from what we learned in our equations graphing unit is that maybe instead of calling this slope, we call it rate of change. And instead of calling this y-intercept, we call it initial value. So a couple things to remember. If we have a table, you want to look for the pattern between the change in y and the change in x. We also need to look for the y-intercept a little differently because in the chart, this is the value where you have an x value that's 0. Remember, if we have a graph and the line is drawn, when we go to look for that y-intercept, it's always going to have the coordinate 0, something. So you either had to move up to get to it or down, but you'd never go to the right or left to give yourself a value other than 0 for the x coordinate. So remember, y-intercept is often called initial value, and just slope is often called your rate of change. So graphs are nicer, I think personally, because you can draw a slope triangle between the points to find your slope or your rise of a run. And then again, you can just visually look at the y-axis to see where your line crosses to get that initial value or your y-intercept. So this side of your notes, again, is just filling in some things to review vocabulary. This side of your notes is where we actually get into the word problems, which we do have to read carefully. Okay, the chart tells us a lot of information, but it doesn't tell us why the total cost is already $6.25 when you're not buying any drinks. So it's very important, again, to go back and read the word problem. This is how we have a purchase of $6.25 already, because they're at the movies and they decide to buy a large popcorn. Then they decide whether they're not buying any drinks. So even before they buy drinks, they're paying $6.25 for the popcorn. Okay, so we're going to use the table, but we also have to make sure we look at the other information that's given to us so that we can make good answers to the questions. So, rate of change. Remember what we're doing in a table is we're looking at the change in y and compared it to the change in x. So what kind of change do we see if we pay attention to this pattern? These can be our x's and these can be our y's. So if we look from there to there, looks like it went up a little over $3. It went from $10 to $13.75, so that tells me it's exactly $3.75. And then if you keep looking, I bet you that's the same amount. $3.75 is the change in y. 75. And if you look at your pattern on the number of drinks, the number of drinks just go up by 1 each time. So we definitely have a slope that's $3.75 when we reduce it. So guys, I'm going to jump down here to part D because we're also talking about the rate of change down here. What does that actually represent in this situation? Okay, what this means, if we buy 0 drinks and we're paying this for our popcorn, when we add a drink to it, we're paying $10. That's a $3.75 increase for what item? It's for buying the drink. So basically the $3.75 ends up being the cost per drinks at this movie theater. So that's how you're going to interpret it with this situation, because we're talking about how much it costs per drink. It's your y value over your x value. So now we're going to jump back up here. It says we need to find the initial value or the y-intercept. Well, again, without having a graph, we have to imagine where this data is going to cross the y-axis when we graph it. So when you're graphing, the number that's on the y-axis is going to have an x value of 0, because remember, if this is your grid, you're staying in the middle, and you're going up to 6.25, and it's going to be right there on the y-axis. So guys, putting those two pieces of information together, we're going to write our equation. Y equals, you're going to grab the slope that you found, and then you're going to grab the y-intercept that you found. And this ends up being the equation that represents how we could find the pricing for the number of drinks if we're already at the movie theater and we already purchased a large popcorn. So that brings us down to part E. What does the initial value or our y-intercept of $6.25 mean? Remember, you've gone to the movies. We're not incorporating ticket prices. All we're doing is we're looking at the price. If we already bought a large popcorn but no drink, that means the large popcorn costs $6.25. And that's what we knew about in the beginning just from reading the word problem. So again, we're working on equations that have slope and y-intercept. And instead of calling it slope, we often call it rate of change. Instead of calling it y-intercept, we often call it initial value. So what is the first thing that we knew about when we got here? Oh yeah, we bought popcorn. We're deciding on drinks. Okay, so initially or at the very beginning is what you look for initial value. Now this recipe question is all about chocolate chip cookies and how much butter we need compared to how much brown sugar we need. So the first thing you're doing is finding the rate of change of the slope. So with a graph, I'm going to suggest that you draw a slope triangle. And they were really nice to us. They gave us two nice, really good points on the grid. So of course you know how to do your slope triangle. Checking your units, you see that they go up by 1. So this is 3 boxes. And your run looks like we've got units of 1 again down the bottom, so it's 4 boxes. And if you wanted to change your slope into a decimal, you could. You could say it's 0.75. But I think I'm going to leave it as 3/4. Okay, and then we're going to come down here and we're going to talk about what this means in the situation. The rate of change means that 3 represented 3 cups of brown sugar. And if you add 3 cups of brown sugar to your recipe, according to this graph, we better add 4 cups of butter to make the cookies come out right. If we don't put enough butter in compared to the sugar, it's not going to have the right consistency. So that's kind of what you need to do when they talk about relating it to the situation. We did it up here with the cost per drink, and that's how we knew it was $3.75 per drink. And down here we have to make sure we label it with the brown sugar compared to the butter. Again, it's always the y values compared to the x when we're doing slope. So now it wants initial value, and in this example we can find the initial value just by tracing it back to the y-intercept. We have 0. And when you write the equation, remember you're going to throw your slope in front of x. You always start with y equals. We could put the plus 0 at the end for our y-intercept, but adding 0 doesn't change the value, so it's better to leave it shorter. And then we have to answer, what does this mean when we have an initial value of 0? It means if we put 0 brown sugar, then we better put 0 cups of butter, because you're really not making anything. Okay, so 0, 0 just represents what the quantities are in the recipe. If you're not making any cookies, you want to make a big batch of cookies, you put 3 cups of brown sugar and 4 cups of butter. And if you wanted to reduce that even further, you could. So your job is to put this in your notebook. I believe we're up to page, let's see if I can find it. I think you're up to 103 and 104. And if I go back to the right page to show you, this is what it should look like when you tape both sides down. There's your title, rate of change, and initial value. And then you have an assignment to work on that lets you practice this topic.